Hello, algebra and honors algebra students. If you happen to watch this video, my 8th period class was freaking out a little bit, feeling a little anxious, so I wanted to make a quick video for them. Now, I told them I would do two problems where I do some type of skip n, like minus 5n after a quadratic part of the problem. But before I do that, I'm going to do two very simple problems here, okay? And I'll point out why I'm doing them. All right, you will see. So I'm going to make my input-output table. I'm looking for the nth term. Okay, so I need 1, 2, 3, 4, 5, and then n. Now, it's pretty obvious to you that it's plus 3 every time, right? Plus 3 every time. Plus 3. So that means it's linear, and it's going to be a 3n. Now, the reason I'm doing this is in the other examples when we're like, plus 2n or minus 4n, what I notice is it's going up 3 every time or going down 3 every time. If that's the case, then that part of the expression is linear and it's 3 times n or negative 3 times n, something like that. Now this of course matches perfectly, right? So I wouldn't do anything to it. So this would just be 3n. Okay, so let's take a look at this one here. All right, I'm going to make my input-output table. There's my outputs. Oops, what happened? There we go. Had a little lag there. I hate when that happens. All right. And I'm going to have 1, 2, 3, 4, 5, and then of course n. All right, so I go looking for my first differences. So that's add 14. And that would be add 22. Okay, and that would be add 30. And let me see, 72, 18, that would be, oh, not 18, 28, and then 10, that would be 38, right? Okay, so then my second differences are plus 8, and plus 8. Oh, I like that. That means my nth term is going to be something like 4n squared, right? Because I have to take half of the 8. It's squared because I'm on the second difference. It's quadratic, so the power is 2. And 8 divided by 2, remember we always take half of the second difference. Okay, it's different if you're doing a third difference, but we're not going to do anything like that. Now, at least not for a while. Okay, so I've got this 4n squared. Now I'm going to do my comparison line. Now, for the sake of the comparison line, I'm going to get rid of all of this. I don't want you to erase your work, but I don't want it in my way for what I'm trying to show you. Okay. Now remember, order of operations is very important here. To figure out this first spot right here, we're going to do 4 times 1 squared. Where the 1 come from? The first term. To do the second one, I'm going to do 4 times 2 squared. And then, of course, this will be 4 times 3 squared. And so on. Now, I had suggested in 8th period, because some people were making some order of operations mistakes, maybe have a highlighter on your desk, and when you have multiplication and exponents, highlighting what you have to do first, right? And then, of course, I've told you before to talk to yourself while you take the test, quietly enough that you can hear your answer, but the person next to you doesn't even realize you're talking. So I'm going to do 1 squared is 1 times 1. That's 1 times 4 will get me 4. Okay, this one will be 2 times 2. 2 squared is 2 times 2. 4 times 4 is 16. Oh, why did I write a 4 there? Silly, Mr. Lawrence. I said 16, but I wrote 4. Okay, and then 3 times 3. 3 squared is 3 times 3. 9 times 4 is 36. Okay, if you want, I can keep going. Let me see here. This would be 16 times 4, so that should be 64. That would be 25 times 4, which would be 100. Okay, now, as I compare, I have to add 2 to turn 4 into 6. I have to add 4 to turn 16 into 20. I have to add 6 to turn 36 into 42. I have to add 8. And for the last one, I have to add 10. Hey, look at this. It's skip counting by 2. 2, 4, 6, 8, 10. That's really multiplication by 2, isn't it? This part, I have to add 2n. So my pattern is 4n squared plus 2n. Okay, hopefully you get it. The 4n squared, you know where that comes from. Now why am I adding 2n? Because on the first one I added 2, 1 2. On the second one I added 4, or 2 2's. On the third one I added 6, or 3 2's. The fourth one I add 4 2's. On the fifth one I'll add 5 2's. On the 17th one I'll add 17 2's. So on the nth one I have to add n 2's, or better said as 2n. Okay? Alright, so go ahead and try this one. Pause the video. See if you can figure it out. Okay? When you're ready, unpause the video and I will show you my solution. Okay, here comes my solution. So let's see here. Gonna make my input-output table. And I'm going to get 1, 2, 3, 4, 5, and then n. And let's see here, I'm adding 2, and then I'm adding 4, and then adding, no, I'm not adding 4, I'm adding 6, silly me. Adding 10, and then I'm adding 14. Do you notice how I'm listening to myself talk, and when I listen to myself talk, I can catch my mistake. Now I like this because this is plus 4, this is plus 4, and this is plus 4. So the second difference are the same, meaning this is a quadratic pattern, so it'll be some type of n squared. I need half of the second difference, which is 2. And then I need to fill out at least 3 of these. So if I put 1 in for n, I'll get 2. If I put 2 in for n, I'm going to get 8. If I put 3 in for n, I'm going to get 18. 4 in for n, 16, 32, and then 5 will get me 50. Okay. Felt like I made a mistake on those, but I don't think I did. Again, don't you erase your work, ever. Don't erase work. Okay. So now, on the first one, I have to subtract 4. On the second one, I have to subtract 8. On the next one, I'm subtracting 12. Okay, I'm skip counting by 4, actually by negative 4. So that means on the nth one, I'm going to subtract 4n. So my pattern is my nth term is 2n squared minus the 4n. All right, hopefully this helps you, ladies and gentlemen. That'll be it for the video. Mr. Lawrence signing off. Have a good night, everybody.